Okay, in section 5.3, we're going to do summation, notation, and area. We're going to use indefinite integrals to evaluate definite integrals eventually. But for now, in the development of the definite integral, we're going to use summation notation. So basically, we're going to familiarize ourselves with some summation notation here. So that way, when we move to our future lessons, this skill will be in place. So the first definition is going to be 5.9. This is in your textbook. Okay, so we pause it for a minute to write down definition 5.9. This is going to be our definition. This is the Greek letter sigma, and it indicates a sum. So we're going from 1 to n, using a sub k, which just represents the kth term of the sum. And it would just tell us to go a plus 1, plus 2, plus 3, plus 4, plus 5, dot, 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 all the way to a to the nth term. Okay, so let's see this in an example. So our sum is from k equals 1 to 5. So we're going to do the sum all the way up to 5. Our 5 tells us where to stop. And we're going to apply this 2k minus 1. So if I was to evaluate that, that's going to be 2. Let's let k be 1 to start, minus 1. Okay, that's the first term. Our second term would be 2. This time what's k going to be? 2. Good. And then minus 1 plus 2. This time k will be 3 minus 1 plus, I'm going to continue down here. We'll have 2. This time k will be 4. And then my last term is I'm going to end at 5. That's where it tells me to end. So it's going to be 2. This time k will be 5 minus 1. Now let's go ahead and simplify that. So we want to find the answer. So 2 times 1 is 2. Minus 1 is just going to be 1. Let's do this next one. 2 times 2 is 4. Minus 1 will be 3. We'll move to the next term. 6 minus 1 is 5. We can kind of see the pattern now, but let's just calculate this out. 2 times 4 is 8. Minus 1 is 7. 2 times 5 is 10. Minus 1, which is 9. Add all those up, and what do we get? Good. So the sum of 2k minus 1 when k is 1 to 5 is going to be 25. Okay, let's see another example. Okay, so j equals 1 to 4, and we're using j squared plus 1. So I'll pause this, I'll let you try it, and then I'll give you the answer. Okay, so check your work. Basically, we plugged in 1. The next time we plugged in 2 for j, 3 for j, 4 for j. Just simplified those expressions, and we get 34. All right, let's look at number 3. So j is equal to 1 to 50, just 4. So in this one, there's no variable here, so we were just going to have 4, and then that occurs 50 times, so you just get 4 times 50, which just simplifies to be 200. Okay, so we have something very basic here. So our index is from 1 to 3, and we're given just k. So what would that tell us to do? 1, the first term is 1. What's the second term? 2, and the third term? 3. So we stop there, and we sum those to get 6. Okay, so we change our index. This time it's not 1, and it's not always 1, so be careful. Make sure you pay attention there. So we start at 3, and we're going to take the sum of all the terms going to 6. So everywhere there's a k, we're going to replace with starting at 3, and we continue till we get to 6. and we don't know any other values, and there's nothing we can add there to simplify it any further than this. Alright, this is Theorem 5.11 right out of your textbook on page 258, so you can either pause it and copy it from your textbook or from here. And then we're going to do Theorem 5.12, which is on page 259 next. Okay, so this is your Theorem 5.12. Make sure you copy this down and you're familiar with it. And then let's see an example. Okay, in this case we're going to use the properties that we just wrote down, and I can rewrite this first term as 2k, and then the sum of, I pulled the negative 1 out front, and the sum of 1 to n of just 1. So 2k minus 1, so the sum of 2k minus the sum of 1. We can break those down. I can also now pull the 2 out front, so just making use of the properties. I can pull the 2 out front, which would leave me with that, and then over here I'll just carry this down, k equals 1 to n of just 1. Now what I want you to be able to recognize is this guy right here. Right? If we look back, let me flip back, that's going to be this k term, so we're going to, the sum from k to equals 1 to n of k is going to be this, so we're going to substitute that in. So it's going to be, bring down our 2. Now we're going to substitute in red our n from the previous page, n plus 1 divided by 2. Minus, and that's just going to give you n when you evaluate this sum. Okay, now let's simplify this. The 2's cancel, so we're just going to get n squared plus n. This 2 reduces with this 2, simplifies, and then you just multiply that out, n squared plus n, and then we have minus n. So that was going to completely simplify to just n squared. Okay, also remember, if you jump back up here, remember this doesn't have a variable there, so it's like the one we did with 4 times 50 the last time. So it would have just been 1 times n, which is just our n. Okay, let's just work with our formulas in this one. If we're given this first summation, k equals from 1 to 10 of just k, because this fits this formula right here, we can plug in this n plus 1 over 2. And I also want to bring your attention over here. This is going to be indexed from 1 to 15 of k squared. So when we recognize k squared, we're going to jump back over to our formula for k squared and use this. So I'm going to write these two formulas over on that next page. I just want you to see where I'm getting them from. Okay, and now we want to plug in n. Well, what is the value of n in this particular case? 10, good, so plug 10 in here and solve, and the value for n on this one on the right is 15, so plug 15 everywhere there's an n and solve, and then check your answer. Okay, check your answers there. Once you plug them in, just do the calculations. Okay, so the directions for this one is express in terms of n. So we know we're going to be using our formulas. Let's first step, break this into the individual components and use properties to rewrite this. Okay, so we recognize the k squared because we have a formula for this. We pulled the constant, the 3 out front. We recognize a formula for this one, and this is just the sum of constants. So now what we want to do is replace this with our formula, and we want to replace this with our formula in our next step, and evaluate this, and then we'll simplify after that. Okay, we pulled our formula, we brought the 3 down, we pulled our formula, and then 5 times n right there is just 5n. Now, you want to go off to the side and scratch work and actually FOIL this out. We're going to distribute this and simplify, and then add all like terms. Okay, on that next step, just add like terms. As an n cubed term, just simplifies to 1/3. You're going to add like terms with the n squared term here and n squared term here, which would simplify to this. Then we have 1/6 n plus 3 halves n plus 5n would simplify to this. Also, if they took it one step further and factored out a 1/3 n, this would be the form.